Today we are going to do differentiability. We have done already functions. Functions, you remember that it is the left hand limit, that limit of the function, that is limit x tends to 0 or x tends to a minus fx is equal to limit x tends to a plus fx, that is right hand limit, is equal to if the functional value that is limit x tends to a minus x tends to a plus is equal to the functional value, then the limit exists. Limit is that. Now we will be doing differentiability. If fx is a real function, and a is a real number, then limit h tends to 0 plus, that is f of a plus h minus fa divided by h. What is h here? H tends to 0. What do you mean by tends to 0? Suppose this is tends to 0 means we will be just not touch, but their distance will be tends to 0, not exactly the 0. Okay, the 0, if it exists, then it is called a right hand limit, right hand derivative. This is called right hand derivative of fx. And the second part is that if fx is a function and real function, a is a real number, then limit h tends to 0 minus, that is f of a plus h minus fa divided by h. H is tends to 0. Again I say that they will not meet, but just gap is tends, they are tending to 0. Okay, then if it exists, then it is called left hand derivative of fx. If left hand derivative of a function is equal to the right hand derivative of that function has got the value k, then we say fx is differentiable at x is equal to a, and denoted by, first thing is that at a, that is f dash a, or dy dx x is equal to a, that is k, or we can write d dx of, or we can write d dx of a, d dx of a. It's okay, fine. Then therefore, if both are equal, then the derivative exists. Then it is the derivative exists. It is just the introduction of differentiability. Differentiability only occurs when the function is continuous. When the function is not continuous, suppose there is a function, suppose here sine curve is a continuous function, sine curve, that is sin x is, this is a continuous function, so on. This is y is equal to sin x, and this is y, and this is x dash, this is y dash, and this is x. It is a continuous function. It never breaks. Then, but tan curve, sine, cos, they are continuous. But now the tan curve is here. That is 0, tan 0 is 0, and tan of 90 degree is here, infinite. And again, this is the tan curve. Or absolute value, I will say absolute value. Absolute value of x, is equal to a. This function, this we say whether it is a continuous function or not. That is, absolute value is equal to x is equal to a implies x is equal to plus minus a. That means x, this is the x-axis, this is x-axis, and this is x-axis, and here that is x is equal to a, this is y-axis, x is equal to a means x is equal to, this is a, and here it is, this is minus a. So your function is here, not plus a minus a. That is, it is not, that means here this is, function will go like this and it will become like this. This is absolute value of x. It is not continuous, it is breaking. It is breaking. So the only the continuous function are differentiable. Okay, stop.